Okay, good morning everyone. Welcome back. Just a little housekeeping on our schedule here. We are on Wednesday, September 11th. You should have the snapshot of that quiz from the Complete the Square Math is Fun. I'm going to go looking for that in your shared folder some point this afternoon. So make sure you have that in there. Also, basically we are working on section 2.5 from the algebra book today, meaning you have quizzes 2.1, 2.2, 2.3, 2.4 that you should, again, I keep preaching at you, right? But if you are way behind on those, I'm telling you right now, I've been doing this a long time, that's not good. You need to keep pace with those and practice those and get those done, because that first test is going to roll around here on Wednesday, September 18th, and you are going to get really crappy grades on those quizzes when Jamie gave you the opportunity to do them as many times as you want so you can get 100%, okay? So make sure you are pacing yourself with your studies and your work on those. I want to talk a little bit more about completing the square and stuff like that. The first thing I want to do, though, is I handed back your painting problem and your banana problem. Most of you did very well. I punched in a grade for each one into Blackboard, and specifically the rubric, so you can see what I gave you for the different categories. Let me just show you how I tackled these. And again, some of you did it a little bit differently and still got the same answer, and that's fine. For the painting one, I said, remember when we were doing like the escalator and distance equals rate times time? Well, so does work, right? Work equals rate times time. You make so much hourly wage at your job, you work a certain amount of time, and you take your rate times the number of hours that you worked, and that's the total amount of money that you get paid. Well, the same thing is like accomplishing tasks or work or whatever. So if work is rate times time, I said the work of Jamie is equal to the rate of Jamie times the time of Jamie, right? And the work of Karen would be equal to the rate of Karen times the time of Karen. So I just said the work is 1. You could use whatever number you want here. I said 1 garage. Paint 1 garage. That was my unit there. So 1 garage is equal to Jamie's rate times Jamie's time. How long could it take Jamie to paint a garage? 12 hours. So what's Jamie's rate? Jamie can paint 1/12 of a garage per hour. 1/12 of a garage per hour. See how I'm trying to keep my variables straight? What can Karen do? Since she can paint it in 8 hours, her rate is 1/8 of a garage per hour. 1/8 of a garage per hour. Now, the most popular wrong answer was, oh, okay, Jamie can do it in 12, Karen can do it in 8. If I average 12 and 8, the average is 10. They'll do it in 10. Somebody tell me why that answer is totally can't work. What's wrong with that answer? I mean, it sounds like it makes sense, right? Well, let's just average the two. Why doesn't that work, Riley? They're working together. If we're both painting at the same time, you're telling me it's going to take 10 hours to complete it when Karen by herself can do it in 8? What, am I slowing her down? See where I'm going with that? It can't be 10, right? So if you used that logic and that rationale, I would say where you fell short is you didn't make sense of the problem very well. And you certainly didn't go back and double check and ask yourself, does this make sense? No, it doesn't make sense. Okay? So, back to what I did here. So, if work equals rate times time, 1 garage equals rate times time, the rate is going to be the 2 rates added together. It's kind of like when Dan was going with the escalator. His rate plus the escalator's rate added together what gave him like double speed. Right? So we're going to have double painting speed, not double because we don't have the same rates, but we're going to add them together. So 1/12 and 1/8 add, if I get a common denominator, it's 2/24 and 3/24, meaning it's 5/24 of a garage per hour. So if I solve for t, it's 24 over 5, which is either 4.8 or 4 4/5, or you could say 4 hours and 48 minutes. Any of those would have been applicable, right? Let's talk about the banana. Now, the banana, it's a cartoon for a reason. It's a cartoon because they were trying to mix you up and they throw all these words and it's really wordy and you got to read it like 7 times before you can even figure out what's going on. Okay? So again, I was trying to get you to attend to precision. Try to label your things appropriately. So I said B is the banana, the part that you can eat. And P is the peel. Therefore, B plus P is the whole darn thing. Some of you did similar to me. Some of you used X and Y. Some of you, whatever. It doesn't matter. As long as you're keeping your stuff straight. Okay? And basically, these are the 2 nuggets of information that you could get from the cartoon. Said the peel is 1/8 of the whole thing, and the banana plus the peel is the same as the banana plus 7/8 of an ounce. Okay? Now, let me show you where an experienced math teacher started running in circles and did way more work than he had to. Jamie starts setting up equations, starts doing substituting, starts moving a bunch of stuff around, blah, 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 and I ended up with 7 ounces, which was the correct answer. You guys with me? 7 ounces for those of you that figured it out. And then I look back at that and I'm like, that was way more work. I must have been running in circles for a while, right? And then I looked at one of yours, because when I was grading all of yours, Riley, it might have been yours. And I looked back and I said, well, look at this equation. If B plus P is the same as B plus 7/8, if I subtract B from both sides, don't I just have P is equal to 7/8? Like there, I just solved for one of my variables. Like what was I doing? Like why didn't I recognize that? Why didn't I see that? It was so simple, right? Because I fell victim to the cartoon and the runaround that was going on. So if you fell victim to that too and you couldn't make sense of it, sometimes math teachers do that too, okay? So then I said off to the side here, well then P is 7/8. And it said that the peel is 1/8 of the whole thing, so 7/8 is 1/8 of the whole thing, so the whole thing must be 7. Duh. I could have solved that in about 10 seconds. Did you do that, Riley? Was it your paper? Some of the rest of you did that too, but I think yours was the first one that I read that I'm like, oh, that was much better than the way I did it, right? So again, there's different ways to tackle this kind of stuff, but it's all about trying to make sense of the problem and keep your data straight, keep your labels straight, keep your equations straight, attending to precision, being precise with what you write down and what you calculate. Comments or questions on either of those? Okay, let's be done with that. I want to talk a little bit about the completing of the square. Now, I haven't looked at any of your quizzes yet. How did it go? The Mathopolis quiz, you can handle it. What you should have figured out, and by the way, I'm going to show you this before I forget. If you want extra practice or extra videos and whatnot on this, if it still doesn't make sense to you, underneath course docs and links, 2.4, 2.5, I already showed you this. We're going to do this today, deriving the quadratic formula, the discriminant. This video is awesome. Remember when I was drawing pictures the other day with the square and completing the square? This guy in this YouTube video does a great job. So if you want to see that again, that's a really good one to watch. And of course, you guys, when you go into your quizzes, there's videos there, there's videos in your textbook. There are more videos on this than you can possibly ever watch, right? So again, you got to determine your level of understanding. Do I need to watch another video? Do I need to watch class again? What part doesn't make sense to me? I'm going to take it upon myself to go, research the part that I'm stumped on, okay? So I want to talk a little bit about what we're going to do with this completing of the square. And you probably figured this out. Like if I have x squared plus 4x plus something, it doesn't matter what it is. That something in this particular case is going to be what? Can you guys do that in your head really fast? It's going to be 4. What happens if I had x squared plus 6x plus, what number would help me complete the square there? Can you do it in your head fast? 9. Who said that? How did you do it, Harmony? How are you doing this so fast when everybody else was still thinking about it?
What adds up to 6 is 3 and 3, and times 3 is 10.
Right. She's taken half of this number, half of it, and then doing what? Squaring it. It doesn't matter what this number is. What happens if I gave you an odd number, like 11x? Half of it is 11 halves. It's usually easiest to work in fractions with this, by the way. Half of it is 11 over 2, which is 11 halves. And what's 11 halves squared? 121 over 4. That would be your magic number. Okay, so why is it always half? Remember we get the x squared box? This is the x, and this is the x, and this is the x squared. Whenever we're trying to tackle the x's, we always put half of them over here, right? And we put half of them over here. That would give us the width of this, and it would give us the height of this, and it's always the same because this makes a square down here. And whatever that number is times whatever that number is, we square it, and that's what gives us our magic number every single time. It even works with negatives. Now, the geometry part doesn't work very well with negatives, but if you understand the whole half it, square it step, you can do it super fast. What happens if it was x squared minus 17x, and we wanted to complete the square on that guy? Well, I'm not going to start drawing pictures. That's going to take me forever. Plus, it's negative, and that doesn't seem to make sense. But what's the shortcut? Take this number, take half of it, because half of it would go on this side of the square, and half of it would go down below. Half of it. And then what are the dimensions of our leftover square going to be? Square it. And then I pull out my calculator because I can't do 17 squared in my head. But it's going to be something over 4. What's 17 times 17? Anybody got it? How much? No, 17 times 17. It's like 3 something. Anyways. So, are we comfortable with that? Kind of the quick. So, what we didn't get a chance to practice in class, per se, was what do you do if the x squared does not have a 1 in front of it? Like, what happens if it's 3x squared plus, I don't know, 4x plus 7 equals 0? And you're like, well, I can't really factor it. So if I can't factor it, what am I going to try to do? I'm going to try to complete the square. I can only complete the square if I can start out with an x squared. But I don't have an x squared. I have a 3x squared. How am I going to remedy that?
Divide.
Yeah, just divide both sides of the equation by 3, right? So if I divide the left-hand side of the equation by 3 and I divide the right-hand side of the equation by 3, so 3x squared over 3 just gives me x squared. This would be plus 4/3 x plus 7/3, and 0 divided by 3 is just 0. So all I did is I rewrote my equation. Now I've got my x squared where I need it, right? It's a 1x squared. And now I can continue on. It's x squared plus 4/3 x plus some number that I can figure out. And if I subtract 7/3 from both sides, the 7/3 would move to the other side. And then I always like to draw in a little line here to remind myself that if I add something here, which I'm going to in a second, I also have to add it over here to make it balance, right? So what's that thing going to be? What's half of 4/3? Well, that would be 4/6. Or I could have said 2/3, right? Doesn't matter. And what is 4/6 squared? 4 squared is 16. 6 squared is 36. And if I reduce that down, that's, what is that if I reduce it down? 4 over 9? Did I do that correct? Yep. There, I just completed the square. Now I could go through and I could factor this guy. I'd have to add these two together, which is going to be a pain in the butt. But I can do it, right? I just got to do a little bit of algebra on this and go with it. So I hope you came away from last time and with that Mathopolis quiz with an idea of what completing the square means and how we do it. I want to take it a step further today. I want you, go ahead and grab a piece of paper, blank piece of paper. You guys got it? One of the things that we want to be able to do is mathematical practice number 2. Reason abstractly and quantitatively. Remember, when we reason with just numbers, add, subtract, multiply, divide, arithmetic with numbers, that's numerically, okay? Or quantitatively. When we reason with letters, with variables, then we're reasoning abstractly. So, I could give you a problem to work on. I'm going to draw a line right down the middle of my sheet of paper here. I could give you a problem to work on that is, say, I'll just use one that I was doing earlier. Let's say it's x squared plus 11x minus 13 equals 0. I just made that up. Okay. Do you guys think you could complete the square on that and you could solve it? Oh, I'm going to even make it tougher. Here, I'm going to put like a -3 in front. There. You should be able to complete the square on that guy, and we'll go through it together. We'll go step by step, right? On the other side of the line, I'm going to write ax squared plus bx plus c equals 0. Notice instead of -3, I wrote a. Instead of 11, I wrote b. And instead of -13, I wrote c. Okay? This is going to be my abstract side. I'm going to reason abstractly. So I'm not going to complete the square on -3, 11, and -13. I'm going to complete the square on a, b, and c. You guys with me? So let's do both sides at the same time. Let's say I'm on this left-hand side. What would I want to accomplish first before I can even complete the square?
Add 13. Or you can divide first.
You can divide first or move the 13 first. Either one would work. Very good. Let's do the divide by -3 first. Okay? So I'm going to divide both sides of the equation by -3. And that will result in x squared minus 11/3 x plus 13/3 equals 0. You guys okay with that? So now let's go over to the right-hand side. Let's do that exact same thing. We're not going to divide everything by -3. We're going to divide everything by what? By a. So divide by a, divide by a, divide by a, divide by a. A, and a. What's left over, this will cancel. So I have x squared plus b over a x plus c over a equals 0. So far, so good? Now, Harmony, what do you want to do?
You can move the positive at this point, so you can subtract the 13.
Correct. That 13/3 is in the way. Does 13/3 make a perfect square that I can factor right now? No. What is my goal? I want to make it into something that is a perfect square. So I'm going to remove the 13/3. I'm going to subtract it from both sides, and I'm going to leave a gap here, plus blank. And if I subtract it, it goes over here, and then I'm going to put a blank over there as well. So who am I going to move to the other side over here? It's not 13/3, it's c over a. I need to subtract c over a. So I'd have x squared plus b over ax plus, I'm going to fill something in that blank, and that's going to be equal to negative c over a because I just subtracted c over a from both sides of the equation. Or another way to think of it, I moved it to the other side and I changed the sign. So far, so good. Okay, back over to my left-hand side. I want to fill in those blank lines. I want to now complete the square. I'm at the part where I'm going to complete the square. So again, you should be able to identify the number that's going to go in that blank. I need half of 11 thirds, negative 11 thirds. So half of that would be negative 11 over 6, right? Half of it. For those of you that might be struggling with that, negative 11 thirds times 1/2 is negative 11 sixths. Half of it is negative 11 sixths, and then what do? Square it. And negative 11 over 6 squared is negative 11 times negative 11 is 121, and 6 times 6 is 36. Okay? So I'm going to add 121 over 36 to the left-hand side, and I'm going to add 121 over 36 to the right-hand side. So far, so good? Okay. Now I got to do it abstractly. I want half of this number, b over a. Well, half of b over a, so b over a times a half is b over 2a. You guys agree? And what is b over 2a squared? Well, that's b over 2a times b over 2a. So top times top, bottom times bottom. So b times b is b squared. And what is 2a times 2a? 4a squared. So I'm going to add b squared over 4a squared. And then, of course, I got to do it over here as well. B squared over 4a squared. Whatever I do to the left, I got to do to the right. All right. Now, if I did that correctly, I should be able to factor the left-hand side of the equation where both parentheses are going to be exactly the same because my square is going to have the same width as it does the height. So I should be able to factor this guy right here into two binomials, x and x, and what's going to go right here? As a little shortcut, you're going to find out that it was always the number that you got when you took half of it before you squared it. Minus 11 sixths, minus 11 sixths. If I were to FOIL this back out, I would get right back to where I started. So I've now factored the left-hand side, and now I've got to do some arithmetic on this guy. I got to add those two fractions together, which is going to require me to get a common denominator, right? Or pull out a calculator, but whatever. What's my common denominator? Let's call it 36. How do I get there? 12. I am going to have to pull out a calculator. I'm just going to cut to the chase. What is negative 13 thirds plus 121 divided by 6? And then I'm going to hit math frac. I get 95 over 6. Is anybody with me? See how I did that? Negative 13 thirds plus 121 over 6. And then if you have a graphing calculator, you can change it into fraction mode. Yeah, go ahead.
121 over 36.
Did I screw up? Yeah. Thank you. Thank you. Negative 13 thirds is my first one. Plus 121 over 36, not 6. I'm sorry. And then I'm going to math frac that. Negative 35 36. Did I do that one right? Negative 35 36. Okay, I should have picked an easier example for our whatever. Are we comfortable with our left-hand, our equation over here? Go ahead.
My question is like when I was learning how to do this,
Yep.
put all of them into decimals.
You can do it in decimals. There's nothing wrong with doing it in decimals. The only problem with doing decimals is every once in a while you get a decimal like this, which is 0.9722222, and it repeats forever.
Yeah, I got that.
Yeah, and you can do that. It's just that when you have the repeating decimal, at some point you're going to have to round it, and it just works so much cleaner to do it with a fraction. I'm not saying it's wrong. It's not wrong. It's just when you get to your final answer, you're going to have to write ... with the little bar over the top showing that it goes on forever. So it's not wrong. I'm saying the fraction works out cleaner.
Okay.
So now I'm going to go over to my abstract side. Right? I should be able to factor this guy into two binomials just like I did prior. How do you get x squared? X and x. This is factoring practice. What's going to be when I, it's going to be plus b over 2a and plus b over 2a. It's whatever number I got when I took half of it before I squared it. So again, if I were to FOIL this guy out, I would get right back to where I started. And then I got to do the same fraction on this guy, but I need a common denominator. I need 4a squared. So it looks to me like I got to take both top and bottom times 4a in order to get a common denominator. So negative c over a times 4a over 4a gives me negative 4ac over 4a squared. See how I got a common denominator with the 4a squared? So I'm actually going to get negative 4ac over 4a squared plus b squared over 4a squared. And now I can add those together. It would be b squared minus 4ac all over 4a squared. That was just a lot of fraction math. Getting a common denominator and adding two fractions together. Because these two fractions that I was adding together did not have a common denominator. So I got a common denominator. This guy was equal to him. Added them together. Gathered my like terms, and I'm good to go. So now I have two of these. And that equals that. Okay, that was a lot. Are you with me? So we have x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. I can do the same thing over here. It's x minus 11 6 squared equals negative 35 over 36. So now I have the same form going on both left and right. Okay, let's solve this guy. Now what am I going to do? Square root both sides, right? Square root, square root. So the square root and the square cancel each other, so I just got x minus 11 6. And over here, I get the square root of 35i all over 6. If you know how to do your complex numbers, you can handle that one, right? Square root of 35i all over the square root of 36, which is 6. So, over here I need to square root both sides. Square root, square root. The square root and the square cancel each other, so I get x plus b over 2a. And then over here, I get the square root of b squared minus 4ac on the top. And the square root of 4a squared is 2a. Square root both sides. And remember, this is plus or minus, because when I square root both sides, there's always two answers. There's the plus and then there's the minus that goes with it. We're almost home free here. Bear with me. How can I solve for x on this guy over here now? I only got one step left. Add 11 6. So if I add 11 6 to both sides, x would be equal to 11 6 plus or minus the square root of 35i all over 6. And I'm done. Or I could do the common denominator. I could say 11 plus or minus the square root of 35i over 6 like that. That would be the other way that I could write that guy right there. This is actually in a plus bi form. So I could just leave it like that. So now I got to do the same thing over here. How do I solve for x? I need to subtract the b over 2a. So x is equal to negative b over 2a plus or minus square root, I'm just recopying, b squared minus 4ac all over 2a. Notice that we have a common denominator. So we can add these two guys together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I have now solved for x. And after that long, painful, awful process, what did I come up with? It's called the quadratic formula. Who else recognized it? A few of you? Maybe you've even memorized it. There's even a Pop Goes the Weasel song that you can sing to rattle it off? So if you've memorized it, great. If you haven't memorized it. But what did we just do? We came up with the quadratic formula. So what is the quadratic formula? Where does it come from? It comes from completing the square. Completing the square and the quadratic formula are the exact same thing. That's where this formula comes from. Why did somebody decide way back when some mathematician said, you know what? Instead of completing the square every time with different numbers, why don't we just do it abstractly where the numbers can be any number? We'll just call it A, B, and C. It doesn't matter that it's -3, 11, and -13. It could be any number for A, any number for B, any number for C. So if we just do the whole completing the square process one time, and we do it on A, B, and C, and we figure out that it's just going to be this relationship right here, then if a math student had to do 30 homework problems, would they have to complete the square 30 times? No, they would just go to the 30 homework problems. Homework problem number 1, identify what's the A, what's the B, and what's the C. Plug and chug. Plug all the A's in, plug all the B's in, plug all the C's in, grab your calculator, punch, 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 done. Now I can go to homework problem number 2, number 3. See what we're doing? We're doing it abstractly so that we can save time. It's more efficient. It's a good idea. Okay? So that is, in a nutshell, the quadratic formula. And hopefully, if you've never seen where the quadratic formula comes from, you now have an understanding of that. Now, if you want to practice it and look at it more, there's an optional Math is Fun for you to click on the quadratic formula. Speaking of the quadratic formula, does anybody know what we call... I'll go back to my quadratic formula. The part underneath the square root sign, right here. So specifically, the b squared minus 4ac. I'm going to circle the b squared minus 4ac. b squared minus 4ac. That has a special name. What is it? It's called the discriminant. What does it tell us? Remember, it's underneath the square root sign. So what does it tell us? It's going to be some number, right? If I punch in my A's, B's, and C's, b squared minus 4ac, it's going to give me something. And then I'm going to take a square root of that something. So what happens when we take square roots of numbers? Sometimes they are real, and sometimes they are imaginary, right? So if b squared minus 4ac is a positive number, I'm going to take the square root of a positive number, which is what kind of number? That'd be real, right? So b squared minus 4ac, it could be larger than 0, meaning it could be a positive number. Do you also agree that it could be less than 0? And if it's less than 0, that means it's a negative number. And if I take the square root of a negative number, I'm going to get imaginary. My answer is going to have an I in it. What's the other possibility? It's either positive, or it's negative, or it's could be 0 right on the nose, right? And what happens when you take the square root of 0? Is that legal? What's the square root of 0? Nope. It's not undefined. Nope. What number times himself gives you 0? 0. The square root of 0 is just 0. You can punch it in your calculator if you don't believe me. The square root of 0 is 0. So notice, remember how I said we always have two answers? There's always the plus answer and there's always the minus answer. Well, what happens if you get a 0 and you take the square root of 0 and you got plus 0 and minus 0? All of a sudden, your two answers, if you add 0 and you subtract 0, aren't you at the same answer? So remember the other day when we were showing the graph where it just touched the axis and it touched it one time, so there was only one answer, and I said it's a double answer? That's what would happen. Your discriminant became 0, so you added and subtracted 0, which doesn't give you a different answer at all. That's why it looks like you only end up with one answer. But in general, how many answers do we get? We usually get 2. And that's why every time you do the quadratic formula, you have the plus or minus. Like over here, we got two answers, right? We got 11/6 plus the square root of 35i over 6, and we got 11/6 minus the square root of 35i over 6. Two answers. So that was kind of a long lecture on where does the quadratic formula come from and what is the discriminant. Again, you can go on Math is Fun and you can visualize the discriminant a little bit more. I gave you some short videos that if you want to watch, completing the square in the quadratic formula and where does it come from. So there's additional stuff going on with all that. So where am I at here? So let's say, let's kind of build a list here. Let's say you want to solve a quadratic equation. You want, to solve a quadratic equation. You should have like a repertoire. You have different tools, you have different strategies that's going to help you solve that quadratic equation depending on the nature of said quadratic equation. What's one thing, and we want to work from the easiest to the most difficult. Why work harder than we have to, right, if we don't have to? So what's a good thing to look for to try right away? Here's a quadratic equation. I need to try to solve it. What's a fast and easy approach if it lends itself to it?
If it's factorable.
Yeah, is it factorable? Can I just factor it into two binomials, use the zero product principle? Usually that's quick and easy if you're a good factorer and if it lends itself to factoring. Okay? What happens if I can't factor it? I could use the quadratic formula, right? So I'll say the quadratic formula. Or the exact same thing of doing the quadratic formula is completing the square. So what you're going to find is sometimes this guy is a little bit quicker and easier because there's not, terrible numbers and you don't have to do a lot of division and stuff going on. Other times you might find that one's a lot quicker and easier, but you're going to get the same answer either way, right? So it's just, what are you comfortable with? What do you want to try? Stuff like that. Let's say you don't want to do any of that. What's another thing we can try? Yeah. What happens if we just graph it, right? So let's go to the one that we just did. Go ahead and open up your GeoGebra really fast here. Let's try, and you guys already know where this is going, but let's try this negative 3x squared one that we were just doing a second ago. So I'm going to open up GeoGebra, and I'm going to punch in negative 3x squared plus 11x minus 13. And I'm curious. No, I screwed that up. I screwed something up big time here. Oh, it was minus. Wait a second. Minus 13, not minus 1. That's better. That's the one that we were doing, right? Is that the one we just did on the paper? Minus 3x squared plus 11x minus 13. So now, once I have it graphed, all I got to do is use my eyeballs or my computer to ask myself, where does the graph of this quadratics always make a parabola, by the way, you guys knew that. Where does it cross the x-axis? Because the x-axis is where it is equal to 0. Where does y equal 0? So where does this guy cross the x-axis? It doesn't, but we already knew that was going to be the case because when we solved this one by hand, what did we find out? What was our final answer on this guy? It was imaginary. And anytime we get an imaginary one, remember it had I in the answer? Anytime we get an imaginary one, It doesn't have any real solutions. So is there going to be any places on our graph where it crosses the x-axis? No, because our graph is a graph of real numbers, not a graph of imaginary numbers. We could do a graph of imaginary numbers. We are not going there in this class. Okay? So we know right away that this guy, without even solving it, it's got imaginary answers. Now, is my GeoGebra going to be able to spit out the imaginary answers? Not with what we're going to do in this course. So does graphing work for imaginary ones in this course? No. But let's say I gave you, let's change it. Let's say the original problem was negative 3x squared plus 11x plus 13 instead of minus. Let's change that. Now when I look at my graph, it seems to me, I'm going to scrunch this down so I can see the whole parabola. It seems to me that I do have real answers, correct? I could solve it by hand. I could complete the square. I could punch it into the quadratic formula. Or I could have my computer do what? Find the points where my little orange curve crosses the x-axis. So I would go to my new point tool. I click on intersect. I'm going to click on my parabola. And then I'm going to click on the x-axis. And where does it cross? At those 2 points. Now, going back to what Ashley was saying earlier, your GeoGebra is going to spit it out in a decimal, whereas if you did this by hand, you would probably spit it out as a fraction. So you've got to be clever enough to know that a decimal representation is the same as a fraction representation, and you can use your calculator to kind of match it up. But notice if I go to options and rounding and I go to like 5 decimal places, you know, big ugly decimal, big ugly decimal. If I did it by hand, I'd have to punch those fractions into my calculator to see if it gives me the same decimal. That would be a way to check it. Okay? Questions on being able to just use your grapher to figure it out? 2 answers again, right? Okay. I'm going to intro, I wasn't going to do this until Friday, but I'm going to do it today. I'm going to intro the assignment that I'm going to give you to work on, and you're going to have a week to work on this. Okay? I want you to go to Blackboard, and at the very bottom of your course docs and links, you are going to see a quadratic calculator template. You guys see it? It's an Excel spreadsheet. I want you to open that. This is going to be kind of your Chapter 2 algebra project, if you will. And it's going to be due a week from today because that's when we're taking our test, right? Okay. If you open that up, you should have the exact same thing that I have on my screen. You guys there? There's 2 tabs, by the way. Notice there's one that says Quadratic Formula, and there's one that says Complete the Square. Okay? So pay attention. Here's what I'm going to have you do. First of all, why am I having you do this? Because I want you to be able to reason abstractly. Not just with numbers, but with variables. How many of you are semi-good with Microsoft Excel? You can do some stuff with Excel? How many of you are total rookies when it comes to Microsoft Excel? A few of you? Okay. How many of you took CIS 170? Almost all of you? Now, if you raised your hand, yes, I took CIS 170. I'm looking at you, Harmony. And you raised your hand and said, I'm a total rookie with Excel. What went wrong in CIS 170? Because isn't a big part of CIS 170 your ability to use Excel, PowerPoint, and Word? Yeah? Okay. That's okay. Here's your assignment. The yellow boxes are the original equation. Okay, the yellow boxes are the original equation. So let's say we were doing the one that we just did on GeoGebra. It's negative 3, 11, and 13. So I would enter negative 3, 11, and 13. Yellow box number 1 is the A, the B, and the C. So that's negative 3x squared plus 11x plus 13. That would be my original problem. If one of these is negative, like let's say this was negative 11, I'd put a negative there. If this one was negative, I'd put a negative there. Okay, I'll just leave it the way it was. So the yellow boxes is for the user to punch in the original problem. I could go to the complete the square one and do the same thing. This would be -3, 11, and 13. Okay? The blue boxes are your assignment. What are you going to do to the blue boxes? You are going to code them. You are going to make your own quadratic equation solver. You're building your own calculator. I built the template for you, and the reason I do that is because when I look at 15 different students' template, it's nice to be able to look in the same spot for everything. Plus, it makes it easier on you guys. You don't have to build your own template. So they're all going to look the same. But what you put in this blue box, and this blue box, and this blue box, and this blue, that's up to you to code it. So let me show you a little bit on cell references. I'm just going to make a new tab on mine here, just a blank tab. I'm going to show you what I mean by cell references. Let's say these were my 3 A, B, and C yellow boxes. And I asked you to punch in values for those 3. So let's say I did -3 and 11 and 13. Let's say those are my 3 boxes. I can do any operation that I want in Excel. Excel is a calculator. I can add, subtract, multiply, divide. I can do square roots, averages. I can do whatever I want. So let's just say in a random box, I wanted to add the -3 and the -11 together. Let's say I just wanted to sum the two for some reason. Okay? One way to do that would be anytime you want to put a formula or a calculation into an Excel cell, you always start with the equal sign. Equals, and then put what you want in there. Now, if I wanted to add -3 and 11, I could do that. I could go equals -3 plus 11 and hit enter, and it's going to spit out 8. Notice what I did is I just added quantitatively. I took a number plus a number and I added it together. That's not what we're going to do here. Okay? I don't want to add -3 and 11 because what happens if later on I change -3 to something else and I change 11 to something else? I'm no longer interested in -3 plus 11. What do I really want to add in this box? A1, that's the name of a cell, A1 plus B1. So if I go equals A1 plus B1, notice it still gives me 8, but now what happens if I change this one to like 9? As soon as I hit enter, watch what happens to my 8. Now it's adding 9 plus 11. What happens if I change this one to a 6? Now it's adding 9 plus 6. What happens if I make it a -7? Now it's adding 9 and -7. Do you see how it changes with it? It's because I defined this cell to be the sum of not the two numbers, but the values that are residing in the two cells. Do you see the difference between thinking quantitatively and abstractly? Quantitatively is with numbers, abstractly is referencing the cell. Could I, instead of adding, I could divide. I could find the square root. I could do any computation that I want, right? So I'm going to give you a hint. Let's go back to my completing the square one. Everybody on your completing the square cell? Let's pretend you were doing this guy by hand. Like this was a piece of paper and you were doing this by hand. What's the first algebraic step? Oh, in fact, I even give it to you. Look at the directions for line 8. It says, make the coefficient of the x term equal to 1. Isn't that what we would do? Make it equal to 1. How do I make it equal to 1? Divide by -3. However, I am not going to divide by -3. I'm going to divide by what? Because it might not be -3 next time you come in to punch in another problem, right? But it's always going to be in which cell? B6. So couldn't I divide by B6, divide by B6, divide by B6, divide by B6? And that's going to spit out new values in the blue box? Okay. Try to figure it out. You have a week to do this, so we're going to have some more class time if you want to ask questions. But see if you can make your spreadsheet spit out answers. Questions?
So we make our own equations and we make our own formulas for the cells.
Whatever you end up typing in the blue cells, if you get it correct, it'll never change. You will never change those again. The only thing you would change then is if you were doing 30 homework problems, you would punch in this for number 1. And then number 2, it would be a different yellow, different yellow, different yellow. But the blues will never change. Does that help?
Yeah.
If you have more questions about this, you can ask when you come back to class on Friday. And we'll have a little bit of class time to tinker with it as well. Okay, see you on Friday.